Assalamu alaikum student. Today we discuss the convex mirror rules reflection. We discuss the first rule. First rule that is the when the ray is coming parallel to the principal axis, when it hit the mirror it bounces back, so that if you trace back the dotted line behind the mirror, it will passes through the focal point. So we discuss the first rule. Here we take the convex mirror. In the convex mirror, this is center of the convex mirror, that is the pole, and focus of the convex mirror, that is the behind the convex mirror. And convex mirror is the part of the sphere, so it is the center of the curvature, that is the C. Principal axis, that is passes through the pole and the center of curvature. This is the principal axis. Now here we take the object AB. This is the object AB. Okay, DJ Alok. Subject name is physics. Physics topic is geometric optics chapter, and topic is the convex mirror. Welcome to my class, DJ Alok. अच्छा, जो लाइव है प्लीज़ कमेंट सेक्शन में कमेंट करें ताकि मुझे पता चले कि कौन मेरे जो है वीडियोस देख रहा है. थैंक यू सो मच फॉर वाचिंग. ओके, here we take the object AB. Now we take the ray that is coming from the tip of the object. Here is the ray that is coming off the tip of the object, and it will reflect when it hit the mirror. Okay, one point is remember that, and when the ray is reflected by the convex mirror, it diverge. It not converge. ठीक है? It always diverge. So here we take the ray that is parallel to the principal axis. It reflect when it hit the mirror. If we trace back the ray behind the mirror, so it will passes. Here we trace back the ray behind the mirror, it will passes through the focus of the mirror. So this is the first rule of the convex mirror. So the ray will appear to come through the focus of the mirror. So here we write the first rule. First rule is a ray that is the parallel to axis a ray that is the parallel to the axis, a ray of light that is parallel to the principal axis. This is the principal axis and this is the ray that is the parallel to the principal axis. Reflect in such a way that it appear to come from the focus behind the mirror. So here, that is the ray of light that is parallel principal axis reflect in such a way that is appear to come from the focus behind the mirror. Okay. Now we discuss the second rule. Second rule, when the ray is directed toward the focus, then it travel parallel to the principal axis. So here we take another ray diagram of the convex mirror. This is the convex mirror. In the convex mirror, that is the part of the spherical mirror. This is center of curvature. This is the focus that is between the pole of the convex mirror and the center of curvature. Here we draw the principal axis that is passes through the pole and center of curvature of the convex mirror. Now here we take the object A, B. If the ray is directed toward the focus of the convex mirror, here we draw the that is the ray that is directed toward the focus of the mirror. When it reflects back, it becomes parallel to the principal axis. So here we write that the ray that is the toward focus. So when the ray is toward the focus, array that is directed toward the array that is directed toward the focus reflect and travel parallel to the principal axis. That is the second rule when the ray is directed toward the focus of the convex mirror. First rule, that is the ray that is parallel to principal axis, it reflect, and if we trace behind the mirror, it coming from the focus of the convex mirror. Second rule is when the ray is directed toward the focus of the mirror, it reflect back and become parallel to the principal axis. Now we discuss the third rule. Third rule, that is when the ray is directed toward the center of curvature, reflect back along the same path. Here we take the convex mirror and that is the principal axis. This is the center of curvature. focus and pole of the convex mirror. Here we take the object A, B. Now we take the ray such that is come from the that is directed toward the center of the curvature. Here is the ray. Increase the tip of the object, that is the A. So here the array that is directed toward the center of curvature, it reflects back along the same path when it hit the mirror. If you trace the ray behind the mirror, it comes from the center of the curvature. So here we write that toward center of curvature, center of curvature C, array directed toward array directed toward the center of curvature reflect back along the same path. So whenever the ray that is directed toward the center of the curvature, it reflect back along the same path. That is the three rule that today we discuss. First rule, that is whenever the ray is parallel to the principal axis, it reflect. When we place the ray behind the mirror, it come from the focus of the mirror. Then we discuss the second rule. Second rule, that is when the ever the ray is directed toward the focus is reflect back and come parallel to the principal axis. And third rule, that is the when the ray is directed toward the center of the curvature, reflect back along the same path. That is the three rule. Now we discuss the last rule. Last rule, when the ray that is hit the mirror, okay, now we discuss the fourth rule. When the ray that it hit the pole of the convex mirror, this is the convex mirror. This is the pole, this is the center of curvature, and this is the focus of the convex mirror. When a ray is hit the pole of the convex mirror, it reflects by the law of reflection in such a way that the angle of incident is equal to angle of reflection. So here we draw the array that is the hit the pole P, and the ray that is hit the pole P are a that hit the pole of the mirror reflect by following law of reflection. What is the law of reflection? That is the angle of incident is equal to angle of reflection. Angle of incident and angle of reflection, that is measured from the principal axis. That is the fourth rule of the convex mirror. When the ray that is hit the mirror at the pole, that is the angle of incident, this is the angle of reflection. Okay, now move to the image formation by the convex mirror. Object at infinity. Here we take the convex mirror and we take the object that is in the infinity position. Here we take the convex mirror in the convex mirror, that is the center of curvature. This is the focus and this is the pole of the convex mirror. If we take the object that is placed at infinity, this is the object AB that is in the infinity position. Here is the ray that is hit the mirror. It diverge after reflection. Here is the also the ray that is parallel principal axis. It diverge after reflection. Here we take the ray that is passes through the center of curvature. It reflect back along the same path. Okay, now we trace the rays back behind the mirror such that it is come from the focus of the mirror. It is meet at the focus of the mirror. So our image is formed at the focus of the mirror. So here we write that object AB is at infinity, ray parallel to principal axis meet at focus after reflection. Image is formed Add focus. Image is formed at the focus. Image is virtual, erect, and very, very small. We also say that that is the highly diminished. That is the image form when the object is at infinity is formed at the focus, or its image position is at the focus, and the nature of the image as is virtual, erect, and very, very small is highly diminished. Okay, now we discuss the when the object is placed between the infinity and the pole. So what is the image formation position? So here we draw the diagram. Here we take the principal axis. This is the pole, center of curvature, focus. Object that is the AB. Array that is the parallel to the principal axis. It reflects after the reflection. We take another ray that is come from the center of curvature. It reflects back along the same path. If we trace this mirror, this ray behind the mirror, it is meet at this point. This is the point where is the image is formed. We know that when the image is formed behind the mirror, it is always virtual and erect. So here is the image that is formed A dash and B dash. So here we write that object AB is kept anywhere between infinity and pole. Array parallel to the principal axis appear to pass through the focus. Here is the ray that is parallel principal axis appear to pass through the focus after reflection. Now we discuss the another ray. Another ray which passes through the center of curvature will go back along the same path. अच्छा, here is the image A dash and B dash is formed. Image A dash B dash form between pole and focus F. Image that is the virtual erect and smaller than object. That is the image formation by convex mirror when the object is placed at infinity and when the object is placed between infinity and the pole. That is all we discussed today. Now we discuss the mirror equation. Okay, now we discuss the mirror equation. Mirror equation or formula relation between object distance, image distance and focal length f. Mirror equation mirror equation is relationship between object distance image distance sorry image distance that is the v and focal length f. Here we take the convex mirror. We know that this is the center of curvature, this is the focus and this is the pole. Here is the ray that is appear to come from the focus. This is the ray that is by principal axis and reflect and appear to come through the focus. This is the object A, B. Now we take the another ray that is passes through the center of curvature. Here is the ray that is passes through the center of curvature. This is the meeting point of the two rays where is the image is formed, that is the virtual and erect, and form is behind the mirror. So here we take the image height, that is the h dash, and as the object height, that is h. Object distance from the pole of the mirror, that we take the u, and image distance from pole of the mirror, that is we take the v. So here we write the mirror formula. Mirror formula, here we use the 1 hour focal length is equal to 1 hour object distance plus 1 hour image distance. Focal length, what is the focal length? That is the distance between focus and pole of the mirror. This is the focal length of the convex mirror. Okay, we also find the magnification. Here we take the how to find the magnification in the convex mirror. We use the formula, that is the height of the image over height of the object. Second formula, that is we use image distance minus image distance over object distance. That is the mirror equation that we use in the numerical for the convex mirror. Now we draw the diagram of the concave mirror. Then we discuss it, mirror formula and magnification. Here we draw the concave mirror. This is the pole, focus F, center of curvature. If we take the object that is between the center of curvature and the focus F, so image is formed that is behind the center of curvature. It is the ray that is parallel to the principal axis and passes through the focus of the concave mirror. Here we take the ray that is the passes through the center of curvature. This is the point where is the two rays meet and the image is formed that is in front of the mirror, that is the real and inverted. So this is the height of the image that was represented by h dash, height of the object that is represented by h, object distance from the pole of the mirror, that is the u, and image distance from the pole of the mirror, that is the v. Okay, focal length, that is the distance between the focus and the pole of the mirror, that is the f. Now we can use the mirror equation, that is the relationship between the image distance, object distance and focal length. So here we write that 1 hour focal length is equal to 1 hour object distance plus 1 hour image distance. Now we discuss the magnification. We can find the magnification of the concave mirror by using the formula of the magnification, that is the height of the image over height of the object. Second formula, that is the minus image distance from the pole and object distance from the pole. That is the formula we use in the concave mirror and the convex mirror. Now we can use these formulas in numericals. We discuss in detail concave mirror, convex mirror, image formations and the rules, and then we discuss the mirror equations. That is all today we discuss.